Hi friends, in the discussion of Turing machine, let us continue the Turing machine as an acceptor. A Turing machine as an acceptor, it is a theoretical device which reads an input string on an infinite tape and determines if it belongs to a specific language. The Turing machine starts with the Q0, that is initial state, with the input string on the tape. Based on the current state and scanned symbol, it rewrites the cell, moves left or right, and changes the states. The acceptance condition is the string will be accepted if the Turing machine reaches the final state. Let us design a Turing machine for accepting language L is equal to 0 to the power of n, 1 to the power of n, where n is greater than or equal to 1. That means n number of zeros followed by n number of ones. That is equal number of zeros followed by equal number of ones. The solution is you start from the left with the initial state Q0. Read 0 and make it as x, then move right to find the first one and make it as y. Now move left to find the next 0 and repeat the step 2 until all zeros become x. That means for every 0 in the left side, you make it as x and find the matching 1 and make it as y. So now all zeros become x and all ones become y if it is in correct structure. That means if there are equal number of zeros followed by equal number of ones. Move left to find the last x and move right if it reaches the blank on reading y. Final state is accepted. If you are not able to reach the blanks, that means final state is not reached. Let us see the states of the Turing machine. Q0 is the initial state. When you find the first 0, make it as x, move right, reaches the state Q1. So when you find zeros, you keep it as 0, move right to find the first one. When you find the first one, make it as y, move left, reaches the state Q2. When you are in Q2, whether you find 0 or y, keep it as it is, then move left to find the x. So when you find the x, move right to go to the next 0 and make it as x, again move right, then reaches the Q1. So again if you find zeros or y, you keep it as it is, move right to find the next one. So you make it as y, then move left to find the next 0. So this has to be repeated until all zeros have become x. So when all zeros have become x and all ones must have become y. If that is so, when you find the y, when you move the state to next Q3, that means right, automatically you find a blank state. If you are not able to find the blank state, it means that there is a mismatch of zeros and ones. So Q4 is the final state. This is the transition table of the Turing machine. The initial state is Q0. If the input symbol is 0, make it as x, reaches the state Q1, then move right. When the input symbol is y, you keep it as y and reaches the state Q3 and move right. When you are in Q1 state, if the input symbol is 0, keep it as it is, come back to Q1 state, move right. If the input symbol is 1, make it as y, go to state Q2 and move left. If the input symbol is y, you keep it as y, come back to Q1 state, then move right. When the state is Q2, input symbol is 0, keep it as it is, come back to Q2 state and move left. When you find a x, the Q2 state will go to Q0, keep it as x, then move right. When the input is y, keep it as y, come back to Q2, then move left. When you are in Q3, when the input symbol is y, keep it as it is and move right to reach the blank state. So when you reach the blank state, go to Q4 and stay there. That is the final state. The instantaneous description of the Turing machine. So as we have seen, Q0 is the initial state. So when it finds the first 0, it make it as x and reaches the state Q1. Then move right to find the first one. So when you find the first one, you make it as y and reaches the Q2. Now we have to move left to find the next 0. So when you find the next 0, reaches the initial state Q0. Now Q0 faces 0, that means this 0 will become x now. Again it goes to Q1 state to find the next one. So when you find the next one, so what it has to do, it will make it as y and reaches the state Q2. So when you find the Q2 state, it moves left, and when it moves left, it finds the last x. So last x and it reaches the Q0 state. So when it reaches the Q0 state and it finds the y, so it moves right and reaches the Q3. And Q3 will move right to find the blank state. So when it finds the blank state, it goes to the final state Q4. That means there are equal number of zeros followed by equal number of ones.